We're still on the EEG to music conversion generator. It works, but it sounds horrible as expected. So try to improve it by doing frequency shifting or some fancier interpolation. So we had a linear interpolation in the code, but that I don't see it anymore. Somehow disappeared. Yeah, this conversion. Yeah, so this does logarithmic. So why the current conversion? It generates too many 0 hertz, which is a bit odd. Just make the output volume lower because it's really horrendous. This is channel 0. Yeah, actually all of them are 0. It's 0 hertz, I don't know why. Then channel 10 I think gives some frequencies. Yeah, the mapping is incorrect. So one thing, because it's suggesting adding a new function. Do we need a new function? Probably not. Getting dominant frequencies. Already doing scaling. Scale AG to MIDI. So instead of a new function, can we update the current one? That we already have. Yeah, because most of the time the frequencies are just 0, and now time the frequencies are very low. So they end up being that lowest frequency node.
Scale_eg_MIDI function to incorporate frequency shifting and scaling. The idea is to modify the function to handle 0 frequencies as rests and apply shift to non-zero frequencies before scaling them to the MIDI range.
Why am I having too many 0 frequencies to begin with? So this is updating scale. Also shifting the values. Before implementing that, why do I get so many 0 hertz frequencies to begin with?
Getting many 0 Hz frequencies from your EEG data when performing FFT, fast Fourier transform, can be attributed to several factors related to the nature of the EEG signals, the way FFT is implemented, and the specifics of your data. Here are some key points to consider. Low variation. EEG signals often have periods of low variation, especially in a relaxed or steady state, which can result in a dominant frequency of 0. Artifacts. EEG data can contain artifacts or noise that are not related to brain activity, such as electrical interference or movement artifacts.
Okay, so I do not expect 0 frequencies. I can take F1 instead of F0.
Window size. The size of the data segment, window, used for each FFT calculation significantly affects the result. If the window is too small, it may not capture enough data to accurately represent the frequency content. Conversely, if it's too large, it might average out the variations over time.
Yes, currently it's 300. So 200 will be it's a window size of half a second.
Signal processing. If the signal is not properly processed before FFT, e.g., the trending, applying a window function, it can influence the outcome, potentially leading to a dominant frequency of 0.
So we're applying so we commented out the window function. Probably should bring it back maybe with a different window type.
Sampling rate. The sampling rate of your EEG data determines the frequency resolution. A low sampling rate might not capture higher frequency details. Quantization error. If the EEG data is digitized with low resolution, it might not capture subtle changes, leading to periods where the signal appears flat.
So I'm actually not downsampling or anything at this stage.
If the EEG signal has a low SNR, the actual brainwave signals might be masked by noise, resulting in an unclear frequency representation.
No, we don't have noise in this. This should be a clear clear EEG. One thing though that I notice, you might need a I need to apply a window. to detrend this. Yeah, because it has to remove the DC component from it. Can window function be used for detrending? I assume it will say okay, how do we apply detrending? It's already using NumPy with defining a function. We need to do it manually. Is the existing function for this? Okay, so we need to fix the data is actually not called data. Fitting a polynomial and subtracting the trend. We should be able to display this as well. Well, right, so this is the trending each segment independently. So that's not what I want to display on the graph. Yeah, let's do this. This looks legit. We don't need this because we already have it up top. The trend function, and then dominant frequencies in the function itself. For each segment break. Have a detrend. And then FFT result.
Asked if a trend underscore data is in the correct format, typically a NumPy array or a list of voltage values. Segmentation. Apply detrending to each segment of the EEG data if you're processing the data in chunks. Otherwise, apply it to the whole dataset. Window function. If you're also applying a window function, do it after detrending and right before the FFT.
Generate the whole get dominant frequencies function. Okay, so this is replacing all this bit. Don't need to call that because we already have it. Trend that, and then we doing everything else on the detrended segment. Instead of segment, still running the thing, yes. Just clear the terminal. And expect it to go there's a lot of 21s in there. So I couldn't hear the beginning of it, but there it is. That's what a seizure sounds like. It was a matter of the problem was that the signal wasn't detrended. Detrending definitely helped. There's still a lot of 21s in it. Just wondering if the end would be different. Where it is in the segment. Seconds. Yeah, these segments are too small. So the problem, those frequencies could be pretty random. So the sampling rate is 400. So if we have essentially with 100 we'll have 4 notes per second of EEG. Makes it also slower. Yeah, obviously there would be much more improvements needed. So this is just a large number that loads the whole seizure. Getting the data there, it's still thinking. Still counting 21s. Yeah, this will keep pounding 21s. 20 was better. There will be some sort of ideal very quickly. Same channel 0. This is a very large number to load the whole seizure, the whole data. And we might continue. Might continue next time. Hopefully it will be more palatable, the EEG music. Seizure song. I'll see you next time.